going to use Desmos for my calculator. Our first example, I'm trying to fill in this table. I have exponential form, where it is written with it as an exponent. I have the list of factors where it is written out with how many there are for the base. Standard form is the overall value once you multiply. So for the first one, if I have to fill in the list, it would be 5 times 5 times 5 because there are 3 of them. Then when I do that, I can either type it in as 5 times 5 times 5, the long way, or I could do 5 to the power of 3. You could pick either way to enter it, whichever's faster. And it should be in standard form as 125. So if I look at the sevens, the list is filled in. So now I'm going to go and make an exponent. 1, 2, 3, 4, 5, 6. There are 6 of them, so it will be to the power of 6. If I enter that in, I don't want to type all of them out, so I'm just going to do 7 to the power of 6 because it's faster. So it should equal, for its standard form, 117,649. All right, the next one is the tricky one. These ones tend to be the most difficult. What I'm going to do is I'm going to use the root button, and I'm going to see if I can square root it and break it into 2 numbers. So I'm going to do a root with 2 on it, 1, 0, 2, 4. I could do 32 times 32. That would work. I could also check. I could see if I could break it by 3. Let's see if I can break it into 3 numbers that are the same number. See how it's a decimal? I can't break it into a number times a number times a number. Doesn't work. I'm going to try 4 just to see if it works. 4 doesn't. I'm going to try 5. Oh, 5 does. I could do 5 would be 4 times 4 times 4 times 4 times 4. So I can go through and I can pick. Do you want to use the 32 or do you want to use the 4? You can choose. You want to use the 4s? Okay, so I'm going to use 4s. 1, 2, 3, 4, 5 of them, which means I would have 4 to the power of 5, which I pulled. 4 to the power of 5. Yeah.
Would it matter if you did like the 4 or 32?
No. So if I did 32 right here, I would put 32 times 32, and then this would be 32 what? Yeah. So the computer will adjust and will check, and as long as it equals this,
okay,
you're good. So you can pick. I just wanted to show you that you could choose.
Yeah.
Good questions. Okay, now we're back to having a power. I like these ones. I need to write 3 4 times. 1, 2, 3, 4. That's my list of factors. When I multiply it, I'm just going to type in 3 to the power of 4 is 81. Not bad. Now I have 1, 2, 3, 4, 5 11s. So that's 11 to the 5th. when I calculate 11 to the power of 5, 1, 6, 1, 0, 5, 1. Now we're given standard form. This is the one that can be tricky. I'm just going to test and see which root will work. So I'll try a 2 on it. I'll try like a 3 on it. I'll try a 4. I'm just going to see which ones work. So, oh, no, that was the wrong one. Root. I'm going to try 2 and see if 625 will break into two numbers equally. It will. It's 25. So let's see if cubed. Cubed won't. It's decimal. I'm going to try 4. 4 is equal to 5. So I'm just seeing which ones they will break into. I can either write 25 2 times, or I can write 5, how many times? 5 would have to be written 4 times. 25 would have to be written twice. I can pick. Which one would you guys like to use for our answer?
25.
25 on this one? All right. So because 25 came from the square root, that means I will have 2 of them, which means I will have 25 being squared. Is that okay? Does that make sense? Did anybody use the 5 for this section? You did? Okay. So then what was your power on 5 when you placed it right here? Power 4. Good. Which would mark it as correct. Good. Next table we are going to fill in. We need to fill in with the product rule. I'm going to do the top list, and then we'll see if you can fill in the bottom. So first one, 3 to the power of 10. I'm going to say 3 to the power of 2 times 3 to the power of 8. Why does that work?
Plus 2 plus 8 is 10.
Yep. 2 plus 8 is 10. Anybody have another number I could use? I could do 3 plus 7. I could do 4 and 6, 5 and 5. Yes. So I can choose. There's no perfect answer. You can have a bunch of them. Quotient rule means I'm dividing. So I'm going to put 15 on the top and 5 on the bottom so that when they minus, there will be 10 left over. So if I had like 17 on the top, how many would I have to have on the bottom? 7 to get rid of the 7 on it. What if I had 20 on the top as my power? I'd have to have 10 on the bottom to get it to become a 10. Yeah. So you can pick any numbers for the powers as long as they subtract to make 10. Now the power rule, if I have 3 to the 5th, that means I would have to have a power of 2 because 5 times 2 is 10. You could do, the only other option for the power one would be 1 and 10. Because 10 doesn't have any other factors. Do you think you can do these 2?
Yeah.
All right, let's try them. Has anybody already done the powers for the 5 in the product rule? What did you put for yours?
8.
8 and 4?
Oh, yeah.
Good job. -8 and a +4 would combine to make -4 when I add them up. Good. Did anybody do? This one's kind of tricky. I need to get a -4. Yeah, what'd you do?
I did -1 on the top and -3 on the bottom.
-1 on top and -3 on the bottom. That would give you a -2 because -1 minus a -3 changes it to a positive.
Oh.
Yeah. Oh wait, it would be a +2. Yeah, that would be a positive.
-1 and -1 and 3. Oh, it's
Let's try that. -1 minus 3. What's -1 minus 3? Okay, that worked. Yeah, that one worked. -1 minus 3 is -4. That's good. And did anybody do the power rule for the -4? Did you do one? No? Somebody else. I think I found someone else, but really good job. Anybody else have an idea? What times what is 4?
2.
Okay. I'm gonna put 2 times 2 is 4, but it needs to be -4. How do I fix?
-2.
Okay, and
Did
you
you
can
make
pick.
one negative?
Just one of them. Yeah, you can pick. Doesn't matter. I'm just gonna make the outside one a negative. Then it's fixed. 2 times -2 is -4. X to the 15th. Anybody do that one? What do you do? 10 plus 5 is 15. Good. All right, quotient. I need a +15.
20 and 5.
25? What did you do?
did 17.
Ooh. I'm going to switch it and try and use 17. Okay. And then what did you put on the bottom? 2?
Oh no, just 2.
Just 2 because 17 minus 2 is 17. 15. Yep. Quotient rule. That one's a tricky one. Not dividing. All right, now the powers. What times what is 15? What'd you do?
10 times 5.
Okay, and it can go in either place. I could put the 5 inside and the 3 out. 3, it doesn't matter. You can pick. So I'm just going to put the 3 and the 5. 3 times 5 is 15. Does it need a negative anywhere? Nope, because it's a +15, it's good. Right. Questions on these two tables at all? Cool. Understanding percents. These ones are a little bit weird. Question A, this is your percentage. So I'm going to pull that out. If I write that as a percent, this is a decimal. If I change it to percent, does anybody remember how many times I moved the dot, the decimal point? Twice. I would go move it. So it would be 125%. That means, this is the meaning, it increased by 25%. Why would I say it increased by 25%? What are percents usually out of? 100. Percents are usually 100. But because mine's at 125, it's been bumped up by 25%. It increased, it went up. For B, I have this decimal. So I'm going to move it. Move, which means I have 40%. What is the meaning of that? Yeah, take a go. What do you think? Decrease is correct. Okay, I'm going to put decrease. What? How did it decrease by 60%? Does anybody know?
100 minus 40.
100%. To get to 100%, it's 60% is missing. So it decreased by 60%. On question C, how many of you, so like, I look at this and I go, oh, it's minusing 10 each time. Is it minusing 10 each time? No, it's not. It's not constant. So what I'm going to do is I'm going to take the new and I'm going to divide it by the original. So my new number, I'm going to say, is 90, and it started at 100. When I calculate that, it's going to give me a 0.9. So that means each time it is being multiplied by 0.9. 0.9. And I'm gonna prove to you that it is doing this, just so you can check your work. So I'm gonna prove that it's multiplying by that. What is 100 times 0.9? What is 90 times 0.9? What is 81 times 0.9? How does that prove that I was correct? Yes, how does it prove it? Yes, all of the numbers align with the table. If they didn't, I would have made a mistake somewhere. Does anybody know if that is increasing or decreasing if it's 0.9, 0.9, 0.9? Decreasing. Good. This is the decimal. What would the percent be for 0.9? 90%, which means it decreases by how much percent? 10. It was decreasing by 10% each time on that table.
Wait, how is it 10%?
So see how it's going 0.9, 0.9. It's taking 90% each time, which means it's decreasing by 10. See how up above we had 0.4? So I'm gonna because it's below 100%, that means it was decreased by 10 to get to 90. It's weird. It's not the way we naturally think about it. Turn the page. We are going to try word problems, which are not as bad as you will think. A restaurant is going to raise all prices by 15%. Does that mean it will go up or down if they're increasing it by 15%? Up. So I'm going to make a note. Increase 15%. Does anybody know what that would make 100% become? 100% plus 15% is 115. It tells me to write an expression with the letter P. So I'm going to move my point. So I'll have 1.15 times by P. That will tell you how much the price would become. This is your answer. That is your expression. Let's try B. A store is having a sale, which is discounting all items 25%. What will happen if you discount from 100%? Would I be adding the 25 or subtracting? Discount means I subtract 25, which means I will be paying 75% of the price. Does anybody know what needs to go in front of the letter P? Yeah. Yeah, say it louder.
Multiplying by 75%.
Yes, I will be multiplying it by 75%, but in the problem, I can't like write a percent sign. So I have to move, I have to move the decimal, so it will be 0.75. Increasing means it goes above 1. Decreasing means it goes below 1. That's below 100%. You're not paying the full price. Next question. The FAA now figures the average checked bag to weigh is 15 pounds. This is up from previous figures of 10 pounds. Find the amount increased. I answered this first. How much did it increase?
5.
5 what? Good. Okay, that's one answer. Then the other question, and the percent that it increased by. Okay, what was the new weight? The new weight was 15. And what was the original weight? 10. When I calculate 15 over 10, what does it give you? What's the decimal? 1 point something. 1.5? I'm going to check. 15 divided by 10 is 1.5. How do I write that as a percent, though, instead of a decimal? How many places do I move the dot? Twice. 1, 2. So that would be 150%. Do you want me to make up another question like this so you can see one more example? No? Okay. If you get stuck on the homework with those, just let me know. The last one is a review. When I look, I have 2 to 6. That is timesing by 3. I can fill in the whole numbers pretty easily. 6 times 3 is 18 times by 3. Wait. Yeah, 3 times 8 is 24, 54. And then times by 3 will be 12, 162. I'm gonna check just to make sure I didn't mess anything up. 6 times 3, 18 times 3, 54 times 3. Okay. Everything is good for the whole numbers because I just multiplied it by 3 and followed. But I can't do the fractions unless I build an equation. I start with 2 and times by 3. And then I'll put a power of x minus 0. I don't need the minus 0. I could just, it won't do anything. So now when I plug it in, I would have 2 times 3 to the power of 1/2. 2 times 3 to the power of 3/2. 2 times 3 to the power of 5/2. 2 times 3 to the power of 7/2. Rather than entering in those huge long decimals. Last one. I'm going from 2 to 6. All that jump from the whole number, that's times by 3, which means the next whole number would be 18, and there's no other whole numbers available. My function would equal, start with 2 times by 3, looks familiar, x minus 0. I don't need the minus 0. It won't affect the x, so I'm just going to scribble it. Now I place this function in here, 2 times 3, replace x with 1/3. 2 times 3, replace x with 2/3. 2 times 3, replace with 4/3. Replace, and replace. Do you remember doing those from a few days ago? Yeah, they look kind of familiar. So because the reason why I just write in the expression with the power is because that is easier to type than, let's do the power of 1/3. I think it's easier than typing in that huge decimal. So I'd rather just shortcut and enter in the expression. But you could go through and put in the decimals if you really want to.